Welcome surfers, it is Joel and this is Rustlers, episode 1.8. In this episode the main topic is the topic about strings. Strings in Rust are a collection of UTF-8 bytes. This collection are wrapped in a safe abstraction. A string slice is a view into UTF-8 text, and a slice doesn't own the data but borrows the data. If I write something like this, greeting, and this variable contain a string slice declared as n string str, is equal to hello Rustlers. Okay. Now I can print the slice. Cargo run. I'm missing something. Let's see. Yes. Okay, the parenthesis is in the wrong position. Perfect. Now I have a string slice printed through the print ln. You can think of a string slice as a window into some existing string data. Because a string slice borrows the data, it's a very lightweight format and is very fast to copy or to pass around. Most APIs that only read text use a string slice. If I need to write a function to shout a message, function shout message str, print this message in uppercase, dot to uppercase. Okay. Okay, I can also try this with a call shout greeting. And I can run again the code. Okay, now I have the same message but in uppercase. In this case I don't pass an owned string but a simple string slice. String, on the other hand, is an owned, heap allocated and mutable buffer of UTF-8 bytes. You create it when you need to build or to store the text in a dynamic way. If I need a string, I simply declare it in this way. Let s equal to string from slice. This is a slice, and with the from function I can create a string. Now a string is mutable, so I can push something inside the string. So s push, and I can push another string slice. So hello Rustlers. Let's print the same message again. And run this code. I need a mutable. It's right. I mutate this string, so I must declare the string as mutable. Perfect. I have this message repeated 3 different times. In this code I print a string slice. In this code I print a string slice through a function, and in this code I print an owned string. Because the string own its own memory, when it goes out of scope, it automatically frees that heap allocation. Conversions between string and string slice are cheap and safe. So if you need to borrow a slice from a string, you can write something like this. Let string 2 equals to string from data. I can transform a string to a string slice in this way. Let slice equal to s. And this is a borrow. To create an owned string from a slice, the opposite operation, you can create slice 2 equal to data, and I can create a string s3 equal to slice dot to string to string. Okay. And this code is exactly the same of this other code. String from slice to. Okay, these two pieces of code are absolutely equivalent. Let's try all of this. Is written? No. I need to write the file and run. Okay, perfect. In this case I don't print anything, so I simply check that I don't have any error by the compiler. The last thing, you can also borrow slice slice of strings by byte ranges. Rust will panic at runtime if you cut through a multi-byte character. This is why string iteration is usually done over chars or over graphemes, not over raw bytes. Let's do an example of what I said. Okay, let s4 equal to string from Fierro, and this is my surname and an emoji. I copy this cute emoji. Okay. Now I can slice the string. Let word equal to s4 range from 0 to 6. Okay. And I can print this slice. So print line word. Okay, let's give a try all this code. Okay, as you can see, I have only fierro, but an emoji is a special character, so is a multi-byte character. This means that if I write something like this, so if I move the range by 2 bytes, the compiler say a thing. The compiler have a message error because the thread main panicked in this case because the number 8, the index 8, is not a char boundary of the string, because the crab emoji is a multi-byte character. If I want to see also the crab, I must write another number, so 11. Let's try again. As you can see now, I can print all the character of the original string. When you design functions or APIs that should accept both types, string and string slice, use a flexible parameter. An example of a very flexible parameter is a parameter that uses a specific trait. I can modify this function to take a type that implement as ref trait for a string slice. So I can recover my text with message dot as ref, and now I can simply print this recovered text. Okay, I can run again the code. As you can see, the result is the same. I have the same text in uppercase, but this function is a slightly more flexible, because with asref you can accept any type that implement this specific trait. For today's video, it's all. See you in the next atom, and don't forget to follow the channel, like, and to keep your thinking cap on.